We move on to the next problem, which is problem number 2 in the lecture. And this one tells that the manometer shown in the figure contains an oil of density 780 kg per meter cube. I shall give you the figure shortly and explain it. Find the absolute pressure of the gas in the bulb. Take atmospheric pressure as 1.01 bar. So, I write down the information given here first. That is for the manometric liquid density. Let me take the symbol for that is rho oil. This equal to 780 kg per meter cube. Also, atmospheric pressure symbol for that is capital P with a subscript A. That is 1.01 bar. This bar is a non-SI unit. Let me tell you, 1 bar is equal to 10 to the power 5 Newton per meter square. Therefore, atmospheric pressure is 1.01 into 10 to the power 5 Newton per meter square, which is also known as Pascal, symbol being capital P with small a after that, PA. Now, let me introduce the figure here. Here is a vessel containing some gas, and there is a manometer like a U-tube, one limb open to the atmosphere, other limb connected to this vessel containing the gas. So when connected, the distribution of the gas and the liquid is as follows. I am showing it here. This is the gas that is spreading from this vessel onto a part of this manometric tube, and the remaining part of this manometric tube is filled up with the oil in question. So a proper labeling will be helpful here. This is gas inside the vessel. This is gas spreading onto a part of the manometer, and the blue colored thing is the same oil spreading in both the limbs. In the right limb, its height is greater. Now, let me take a few points as well. Here is a point shown in this red dot, a point at the surface separating the gas from the manometric oil. And similarly, I show here a point with the red dot at the free surface of the oil in the right limb. It is given further in the figure itself. This is a part of the question that this difference in height between the liquid columns in the two limbs, this is, if I take symbolically to be H, this H is given in the figure itself to be 45 centimeter, which is 0.450 meter. The question is to find out absolute pressure of the gas in this vessel. So first of all, we just draw a horizontal line to the point at the separating surface between the gas and the liquid. So let me mark a few points on my figure. This point at surface separating the oil from the gas, I'll call this point as say A. And another point at the same level in the right limb, this point I'll be calling it as B, and the point at the free surface of the oil at the right limb, this point will be calling as C. Now this is atmosphere, it's free to the atmosphere, therefore we can write down the pressure at the points. These are all absolute pressures. PC is equal to atmospheric pressure. Then this height is equal to H, therefore you can write down the pressure at the point B is equal to the pressure at the point C plus, the formula is rho GH, here rho for the oil, symbol for that is rho oil, into G, free fall acceleration, into height of oil column above the point B up to the point C, that is H, so rho oil into GH. Next, since B and A are the points at the same horizontal level within the same static liquid, that is the oil, therefore you can write down the pressure at point A must be equal to pressure at point B. And then you consider any point inside this gas spreading inside the vessel and also a part of this limb. You see, since the difference in height between any point inside the gas and this point A is so small that you might ignore the contribution in pressure because of a small column of gas. I say once again, the density of gas is so small, if I choose any arbitrary point inside the gas anywhere, you follow my cursor anywhere from here to here, the difference between the heights of these 2 points, this point and this point, will be so small that value of rho g h for that small column of gas will be negligibly small compared to the other values here. Therefore, we might argue that for the gas at any point inside the vessel, pressure is the same as the pressure at the point A. Therefore, I can write down that the pressure of the gas, remember this is absolute pressure of the gas inside the vessel, that equal to pressure at the point A only. So let me combine all the results I have written down so far. I can write down that the absolute pressure of the gas inside this vessel equal to pressure at the point A. Just keep on going one step before. PA is equal to PB, but then PB is equal to PC plus rho oil into G into H, but then again PC is equal to atmospheric pressure, therefore it's coming out to be PA plus rho oil into G into H.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.